go away. 11.4. Now, slope. This one was easy. 3. Why was it easy? It's in slope-intercept form. We've learned how to deal with this. And what is this? This is just a line with a y-intercept of -7 that has a slope of 3, right? Is the slope changing anywhere in there? That's kind of what made it easy. If the slope never changes, you just have one equation. But what if we had a function like this? And I asked you for a slope. Well, you can't give me a slope for this because the slope's changing. This slope looks very, very steep. Here it looks like 0. Then it's negative. Then it's positive. Then it's 0. Then it's negative. Then it's 0. Then it's positive. The slope is ever changing. This is actually the majority of what calculus is about. That's why last section in our book is pretty important into it. What we need to find a way to do is find an instantaneous slope. Say, well, we can't find a general slope. So what about at any given point? What's the slope right here? Well, how do we find slope? How did you find slope back in geometry? Rise over run. You needed 2 points, and then you took the difference in the y's and the difference in the x's, right? So you took 2 points. So let's say we tried to do that for this one. I want the slope at that exact point. So 2 points. Do you think if I chose this point and this point, it's going to give me a very accurate slope for that exact point? No. If I were to connect those dots and find that slope, that's like, but our slope is most definitely, so that's not very accurate. How do you think I can get as accurate a slope as possible? If I have to choose 2 points, what's the way I should look for 2 points that's going to give me as accurate a slope as possible? I'm sorry? Yeah, really, really close, right? And it doesn't make sense that the closer we can get to that point, the more accurate it's going to be. Well, that is how this is going to tie into what we did with limits. Write down this formula, and I'll explain it. Write that down. Instantaneous rate of change. There's technically multiple formulas in the section, but I don't see the point of doing all of them. This formula kind of encompasses all of them. We'll just deal with that one formula. Believe it or not, this is nothing more than the slope formula you did in geometry, which is written a little differently to be a little bit more universal. Above. Oh, that's I'll talk about that in a second. Now, before I talk about that exact formula, let's talk about this. What did you tell me just a minute ago was the formula for slope? Does anybody remember the exact formula for slope? That's slope-intercept form, right? Yep. X2 minus X1. Believe it or not, that's exactly what our formula says. Now imagine this. We said, well, we're just talking general terms, right? We just said a second ago, we want to get points as close and close as possible to our point, right? Well, they're just saying, think of this as a slope formula. Say here were the 2 points I was choosing. Well, I should change colors. Let's say this point and this point, right? Those are the 2 points I chose. Let's call the distance between those 2 points, if we were to subtract them, let's call the distance between them, that actual difference, h. I just picked a random letter. Well, that's the letter they chose, but that's all it stands for. H just stands for the distance between the 2 points you choose. All right? Now, if this distance is h, right? Well, let's say, let's make up a distance. Let's say this was originally, the 2 points we chose were f of 0. Well, we're just 0 and 3. Okay? Do you agree with that? 0 and 3? Just from the drawing? We chose the point 0 and 3. So h is going to be 3. It is simply the second point minus the first point. What are their y values? Well, their y values are f of 3 and f of 0, right? Doesn't that mean that's like kind of the functional way to say the y value? The y value is 3, f of 3. The y value of 0 is f of 0. So this is just saying this is one y value, this is the other y value. Now that one's a little easy to see, but let's look at a different one. Like, let's say we chose this point and this point. We'll call this x equals 5, x equals 9. What would my h value be? 4. This would be f of 5, right? Oh, crap. And what would the other one be? F of what? 9. How'd you get that? Well, yeah, it's written right here, but it's also just your first point plus whatever your distance was, right? That's why it's written f of a plus h, to say, regardless of what point you choose, one of them is going to be your starting point, the other one's going to be, well, however far away from your first one you were. So if we had a distance of 4, so it would be f of 5, f of 9, which is the same thing as f of 5 plus 4, where we started plus how far we went. So that's what that formula says. It's just a universal formula for difference in the y values divided by the distance, or the difference in the x value. Now the limit says we have agreed that the most accurate slope we could find would be the one closest as humanly possible to our point. If we could find 2 points that were so infinitely close to our point, that slope is going to be pretty much exactly right. So they're saying, well, let's use this formula, but let's say h is going to be so small it's approaching 0. That way our points are so close together, our slope is going to be pretty much perfect. This equation is going to give you another equation. You're going to punch in a function, like, we'll do some examples in a second, like x squared. We're going to punch x squared into this equation, and I'll just show you in a second, and it's going to generate for us another equation. So we can just punch in any x value, like 3. And if we punch 3 into our new function, it'll say your slope at that point is, boom, and that'll be your instantaneous slope coming from that formula. Let's look at one. Let's look at one. Let's look at several. All right. Number 1. There's our equation. Now that one's simple, and I like that we start with this one because you all already know what the universal slope on that one is. What is the slope of number 1? 2. So we already know what it's going to be. It's to find the slope of the tangent line at a given point. But let's see if we can come up with that using our equation. The limit. Oh, I never answered Hannah's question. This tick mark right here, this function, the new function we're looking for, is called a derivative function. Every function has a derivative for which you can find its slopes. So that tick mark simply says, hey, we're going to find the derivative for what must have been originally f of a. So the tick mark means it's the derivative of f of a. Alrighty. So we're going to take the limit. As h approaches 0, I'm not going to write this every time, but technically it's going to just follow along with the problem. F of a plus h minus f of a over h. You literally punch in, here's f of x. Remember back when we were evaluating functions, if I said what was f of z of this function, wouldn't it be 2z plus 3? Remember, we even did things like f of x plus 2, and you had to plug in x plus 2 for every x value. Same thing. I'm punching in f of a plus h first, so I need to punch in a plus h for every x in the problem. So it's going to be 2 times a plus h plus 3 And then it was minus f of a, right? So minus, I'll put this all in parentheses, f, oh, sorry, what am I doing? 2 times a plus 3, all over h. Before I go any further, make sure we see this. All this is the original function with a plus h plugged in for the first x and a plugged in for the second. So they're both just the original function with those things plugged in. Would anybody like me to explain that a little bit more? All right. Because it wants the whole function. It says what the whole function, so here's the function, 2x plus 3. The only thing it's changing is, instead of x, we're punching in a plus h. So think of this as 2x plus 3, so we just took out x. Same thing for this one. Okay? Now, technically this limit's going to come on down, but I'm just going to leave it off, so don't feel like writing it every time. Now, at the top, we have some canceling. If we were to distribute, that's 2a plus 2h plus 3 minus 2a plus 3 over h. Does anything cancel on the top? The 2a minus 2a, what else? Oh, I'm sorry, this is minus 3. The negative distributed. What was it? 3's are going to cancel. And what'd you say? Now, you couldn't cancel that originally. But now that you've canceled all this other stuff out and you're left with 2h over h, now you can cancel it. And what's this thing equal? 2, which is already what we knew it was. Now, this one's kind of pointless. It says, technically, and this is why this could technically be a complicated one to start with, because technically this is a function. You're always going to get a function. But this one, is the slope changing anywhere in here? No, so the slope's never going to change. All these other ones, we're actually going to get some kind of x function when we're done. But this one we didn't because it was a line. The slope doesn't change. It's kind of boring. There's technically another step, but since there's no h's or x's or anything left, there's really not a whole lot we can do with it. So we're going to go ahead and go to the next example. But the answer for this one would just be 2. That is the slope for every point in this function. Now it asks just for the slope at this point. Well, if it's the slope for every point, then that point's just kind of included, so it's just means 2. Of course, that one we knew just by looking at it. Let's look at number 3. That one will get a little bit more of a different answer. Number 3. Here we go again. Limit. Oh, sorry. As h approaches 0, of f of a plus h minus f of a over h, plugging that into our function, that's, let's see, a plus h squared plus 4 minus a squared plus 4. I just punched in a plus h for x and then a for f, all over h. Let's see, the last one they all canceled, so technically we didn't have to do anything, but every other time you're about to find out. The limit, we are actually going to evaluate this limit. The problem was, like, remember yesterday, I think, no, it wasn't yesterday. The day before, you had to do limits, and it was like, what was the limit of the function as x approaches 1, and the function was just 8. There was nothing you had to do. It was just 8 the whole time. That was like what happened with the last one. But everything else, we'll start having stuff you can do. So, if you just do all this, you get a squared plus 2ah plus h squared plus 4 minus a squared minus 4 over h. That's all I did was FOIL this and then rewrite everything. And distribute my minus sign. Yeah, when you FOIL this, remember it's not just a squared h squared, you have to FOIL a plus h times a plus h. Hmm? Yes, we can. What cancels? tell me, I'll do it. A squared, 4, anything else? Nope. So let's rewrite what we have. One second. I think I see what you're saying. That's 2AH plus H squared over H. Does anything factor out of the top? In H. So that's H times 2A plus H over H, right? Now it cancels. H's. What are you left with? Now, unlike the last one, that's an actual equation. Now, when the dust is settled and everything gets canceled as much as it's going to, and if you do it right, the H in the bottom should always go away. If your H in the bottom doesn't cancel, you're going on to me. Yeah. All right. Now, we're ready for a limit. Does our limit say anything about A? No, it's just for H. So as far as it's concerned, this isn't going to be touched. All right? Remember the other day when I said the whole section was about how you can break apart limits, but it really was more relevant later on? Today is where it's relevant. Essentially, when you take the limit of this thing, it's the same as doing this. The limit, as H approaches 0, of 2A plus the limit as H approaches 0 of H. Now again, you can plug it in, just like the other day. If you plug 0 in for H on this equation, is there even an H in this equation? No. So it's not going to change. That one's just 2A. Plug H into this equation. Plug 0 in for it there. What's it going to be? 0. So it's just 2A plus 0. That is your equation. That's your finished product. Once you've plugged in the 0 for every H, and you could have just done that here. I was just trying to show you that's how it would break up. Once you've plugged in the 0 for every H, whatever's left, in this case 2A, is your function. Now we go back to the top. They want the slope at -1, 5. What? Okay. Only thing we really need right there, only thing we really need for the first part is the -1. That is our A value. That's where it's telling us to start. So we plug -1 into this equation. Now what's our slope? -2. That is your slope at -1, 5. You have answered part A of the question. It's -2. It's just an x value. See, the original function, f of A, well, actually, I had it in here. A plus H, A stands for the starting x value. It stands for the x value that you're finding your slope for. H stood for the change in the x, but H actually stood for that spot. So, when you're done with your function, this is basically just, think of this as f of x instead of 2a. Think of it as your derivative function is just 2x, if you want to think about it like that. This is essentially that. And then you just punch in your x value, and you get the -2. We'll do some more. I think it'll be a little clearer once we do some more. So that's part 1. Part 2 said, find the slope-intercept form. Does anybody remember, well, y equals mx plus c, right? But does anybody remember rather than play that game, let me just show you. Point slope form. You might want to write this down. You're going to need it a few times today. It's a flashback to geometry. To actually get the what am I talking about? Stop. I'm sorry. What am I saying? You don't have to do that, because this equation did it for you. Part B in the problem said, find the slope-intercept equation. The equation is this. 2x. It was right here. I just changed the a to an x. And you'd label that f prime of x. In other words, the derivative of our original function, which is the instantaneous slope function, is right here. Here's the equation. Here's your actual slope. Well, here's the thing. Here's why that's happening. Technically speaking, the book did not want us to do this. The book broke, all the problems there are the exact same. All of them. They're just like this. The book didn't want you to start out doing this. They gave you a slightly different version of this formula than, if we actually, you know where I had you record this from your book? Right above that in your book is another equation that's almost exactly like it. And you were going to have to do two steps. You were going to have to, that equation gave you the slope, the -2, and then you had to plug it into y minus y1 equals m times x minus x1 to get the second part. Well, I think, what's the point of doing something just like it and adding another step? So I cut that step out, which is why it seems like it's going in reverse order. Because technically speaking, we don't know this formula yet, but I don't see the point in waiting for it. So let's look at another one. How about 9? That one looks a little harder. Number 9. We're just going to do examples, examples, examples. That's everything we're doing today. And we're just going to keep doing it until the cows come home. I don't know where that expression came from. All right. So I'll rewrite it every time. H approaches 0. F of A plus H minus F of A over H. Again, A is just a filler for X. So, here we go. F of A plus, I'll actually just write it up here. F of A plus, sure. Before I even start with the equation, I'm just going to find out what these two things are. F of A is just 2A squared plus A minus 3. Just plugging in there. F of A plus H is going to be 2A plus H squared plus A plus H minus 3. Now I'll simplify that. I'm just saving myself some complications when I actually plug it into the formula. I know it's easy, but there's just no way around that. Yeah. Sure. I got all that? Yeah. F of A plus H, I literally plugged A plus H in for every X. 2 times A plus H squared plus A plus H minus 3. That's all I did was I punched in A plus H for every X. Now, this one I could simplify. A plus H squared, when you FOIL it, is A squared plus 2AH plus H squared. That's what this is. I went ahead and multiplied through by the 2. 2A squared plus 2 times 2AH is 4AH plus 2H squared. And then the rest of it's just the same as it's written here, plus A plus H minus 3. All I'm doing now is I'm going to go ahead and find what it is I need to punch into my equation. Just trying to save myself a little writing. So what I've done is, this is exactly what this is going to be. So I'm going to plug this into this, minus F of A. I'm going to plug this into that. And now I can just immediately start with the canceling process. So I need to reflect that. Here's the face of the name. Okay. This part, just this, is just this. It's just carried down. Let's get rid of it. All of this is just this. I FOILed A plus H. You got that. And then I multiplied by 2. Right? So I multiplied this by 2. You got that. No, the 4 came from multiplying 2 by 2a8. 2 times 2 was 4a8. I foiled a plus h. No, I like the question. I'm glad you're asking. A plus h times a plus h. When you FOIL, that's a squared plus ah plus another ah. I didn't really write that very well. Plus h squared when you FOIL. So that's a squared plus 2ah plus 2. You good? That's where the top red portion came from. I see. From the original function. All right. Before we go any further, is there any other questions I can answer? This is a question for him. I took that too.
And you would have everything in the middle. Everything in the middle of the
Yeah. No, everything. 2 times a squared, 2a squared. 2 times this, 4a. 2 times h squared, 2h squared. Other questions about where any of that came from? All right, we're ready to plug it in. So I'm going to plug those into this formula. And I basically saved myself some work. I'll go and write the limit one last time, even though I just don't feel like writing it. All right, so the limit of, now I'm going to write all that down. 2a squared plus 4ah plus 2h squared plus a plus h minus 3 minus 2a squared plus a minus 3. I subtracted the second one from the formula. The important thing today is that you remember to distribute the minus sign. That's going to make this minus 2a squared minus a plus 3 when you distribute that minus all the way through that parentheses. All over h. Again, if you do this correctly, the same kind of thing should always cancel. Pretty much everything without an h should cancel in the top if we did it right. Plus a, minus a, cancels. Minus 3, plus 3, cancels. 2a squared, minus 2a squared, cancels. That should always happen if you did it correctly. What does that leave you with? That leaves you with 4ah plus 2h squared plus h over h. What factors out of the top if you did it right? And h. And it should always factor out of the top. You're left with 4a plus 2h plus 1. I'll stop right there. Is it really loading? When you pull h out of these three terms, it doesn't just go away. You should be able to multiply it back through because a 1 is taking its place. If you multiply this back through, you should get that 4ah plus 2h squared, 2h's. Well, I need something here to multiply by h, so I'll get the h back if I were to multiply. Now, what cancels? The h, as it should always do. That cancels. In the very beginning? Because you get 0 over 0. Oh, no. You mean back at this step? Right here? You could have. But I like to draw it out like this so people see how it affects the rest of the equation. Okay, so that brings us to this point. The limit. Let me switch colors. As h approaches 0 of 4a plus 2h plus 1. Okay. You mean what, this? Well, the original equation had this. And you're supposed to write it every time to remind yourself. I just don't because I don't like to write the same thing every time. Yes. Your finished product, if you do this right, should not have any H's. Because look, I've gotten it down to this, right? Right? Now I'm supposed to take the limit as H approaches 0. So you plug H in. You plug 0 in for that. So it's going to be 4A plus 2 times 0 plus 1, which is essentially 4A plus 1. Yeah. That would be what? You're right. And there's your function. That is your f of x. Your derivative, your equation for the slope is now 4x plus 1. What were you saying? Yep. You plug in 0 for every h. Yeah. Essentially, the equation, you just punch x in for a, boom. There's your equation. That should say f prime of x. What can equal 1? Oh, you mean the actual point? Very good. We did part B first. You come back up. Now we need to find the slope at this point. You don't need the y value at all. You would have needed that if you were doing it the old way. Because remember how I said they wanted you to do point slope form? And you would have needed the y and the x. But you don't need that now. You plug 0 in for x. So that's because we're looking for an instantaneous slope. In fact, before we even do that, this equation will tell me the slope at any point on our original function. Oh, what was the slope at 7? 4 times 7 plus 1, 29. At our original function, the slope at x equals 7 would be 29. What would be the slope at negative 5? Negative 5 from 4 is negative 20 plus 1. The slope of our original function at negative 5 would be negative 19. That's what this function is. The instantaneous slope for any point on that original. This is a slave of the original. It's not its own function. Yep. What B? Part B was this. Oh, that's that one. Yeah, that's part B. I'm sorry. I was thinking in terms of graphics. I was like, where's B? Gotcha. Yeah. A, you plug in the x value. It was 0, right? So you find f prime of 0. That means what was the slope at 0? And it's just 1. You're done. That's part B, comma part A. I'm going to put another one up there. Let's try it on your own. See how it goes. We'll do one of the complicated ones like square root of h in a second. These are the ones, this is essentially what you're doing all day. This is the more clear instructions of what you're doing. It's the exact same as the last one, so don't even look at the instructions. Same thing, except they want you to find it for 2 different points. Well, screw it. We'll just do one of the originals first. So try number 10. Yeah, try number 10. I'll pull it off on its own. And I'll come around and answer questions. This is the one we're working on. We're looking for a slope, an equation to give us the slope at any point. And Will do. It should be all minus 9. Minus, I'm saying, because it's you get minus to those.
Right. Your function should be 4x minus 1. That should be your derivative function. That's what your equation is. Your value, when you put 0 into that, 0 minus 1 is -1. So your instant slope should have been -1. Your equation should have been 4x minus 1. Is there something to look at?
Did you distribute them when you first did it? I'm guessing if that happened, it was in this early step. When you had f of a plus h, the first one should have been the same as last time. 2h squared plus 4ah plus 2h squared. Then it should have been minus a plus h, which would have made it minus a minus h plus 5. When this distributes. If you got +1, please make sure both of these were minus signs in your original f of a plus h. Because when it's minus this, then that negative will distribute. Other questions from this problem? All right. So we've gotten squareds pretty much down. The next ones will be cubed and square root, but the math will be the same, it's just a little bit more complex around the edges. Let's just jump ahead to one of these other, well, no, it's not. How about we do all of them, but stop with squares? We do have time. Now, it's just going to take one day out of review, but let's face it, I mean, I think that's okay. Let me look at this. The only thing we won't be able to do is problems like this, this, this. All right, we can do that. We'll stop, but I'm going to tell you exactly what I want you to do. Yes. Yes. I think it's like that. Let me, 1 second, people. Let me write this thing. It'll be 7. Don't bother writing this down because I'm going to change this assignment like crazy. Page 280. Again, don't write that down because that's not what we're doing. And it'll be, let's see, 2, no, I'm sorry, yeah, 2 through 12, even. We'll be finishing this tomorrow. And then on the other one, whoops, too far. Let's see, it'll be 16, 16. All right, tomorrow we'll get into the x in the denominator functions, square root functions. Today we'll just work on the squared and standard functions. So you can practice formulas. These, we didn't do one of these, but it's the same thing. Only difference is, instead of finding one slope when you're done, you'll find 2 slopes. Like, they want 2 separate answers. So you'll find your equation, and then you'll plug -1 into one of them, and then 3 in, and you'll have 2 answers instead of 1. Only difference. Okay, in that case, here is your modified assignment. You can get started. Here's the thing, though. If I'm going to make this much shorter, oh, we only got 20 minutes. Wow. Never mind. This is not if you turn this by the end of the day. But you definitely need to have it done by tomorrow, or you're going to be behind. It'll be page 1080, 2 through 16 even. Ooh, that's a bit long. 2 through 12 even. 12, and then 16 through 20 even. 2 through 12 even, 16 through 20 even. That is it. This is a long lesson.